Good morning, everybody. Today is 18th December 2020. The day is Friday, and right now I am in the 10th Cambridge class. My name is Ferhan Mazher, and the subject we are studying is Physics 5054. This is 10th Cambridge, and we are working on the chapter of electrostatics, or we also call it static elasticity. We are working on it, and this is I think, the fifth lesson, the fifth lecture on this chapter. And today we will learn a very important thing. We will learn some hazards of the static electricity, and we will also try to learn, if we got the time, we will learn about how this static electricity thing is used in different applications. So, but before we go into that discussion, let me explain to you a phenomena in which what happens that when you bring a charged body near an uncharged body, so what happens that that uncharged body is attracted to the charged body. For example, let me show you a diagram. Okay, so on your screen we have a diagram. It's yeah. Okay. So on your screen, you can see that we have a polythene rod which is negatively charged. And when you bring that negatively charged rod near the aluminum foil, the aluminum foil is uncharged basically. The aluminum foil, because it is made up of metal and it is uncharged, it's neutral basically. It has free electrons in it, and but everywhere the positive and the negative, they are equal to each other. So the aluminum foil as a whole is neutral. It's a metal, it's a conductor. So what we did, we brought a charged polythene rod on the top of the near the top of the aluminum foil. So when you will bring the charged polythene rod on the top of the aluminum foil, what will happen? Due to that negative charge, the electrons which are in the free electrons which are in the top of the aluminum foil, they will be repelled by that negatively charged rod. So what will happen, because we know that the free electrons, they can flow, they can move around in the body of the matter. So what will happen? The free electrons from the top, they will be repelled, because we know that the light charges repel each other. So the free electrons from here, they will be repelled and they will go to the bottom. So what will happen, that at the bottom there will be excess of electrons. And on the top of the aluminum foil, we will have deficiency of electrons because of this negatively charged polythene rod. So the free electrons have gone downward. So on the top, because of the deficiency of the free electrons, what will happen? This top will act as positively charged. And the bottom of the aluminum foil, because there is excess of electrons, it will behave like a negatively charged. So aluminum foil still as a whole is neutral, but its top is acting as positively charged and the bottom is acting as negatively charged. And this happened because we brought a charged polythene rod near the top of the aluminum foil. And so you see the aluminum foil, now its top is positively charged and the bottom is negatively charged. And this happened because we brought another charged rod near the top of the aluminum foil. This is called electrostatic induction. This phenomena is called electrostatic induction. So due to the electrostatic induction, the aluminum foil appears to be charged. its top is positive, its bottom is negative. And we know that the positive and the negative, they attract each other. And we also know that the negative and the negative, they will repel each other. For example, here this rod is negative and the top of the aluminum foil is positive. So they will have attraction with each other. This negatively charged rod and this bottom of the aluminum foil, they both have the negative charge. So they will be repelling each other. So you see, at the same time, the polythene rod is attracting the top of the aluminum foil and it is repelling the bottom of the aluminum foil. The top is being attracted because it's positively charged and the bottom is being repelled because it's negatively charged, and our polythene rod is also negative. Like charges repel each other and the unlike charges attract each other. The attraction is more in this case, the case which is shown on your screen. The attraction between the negative and the positive is stronger, is more, the force of attraction is more as compared to the repulsion between the negative and negative. The reason is the distance. Because the distance between the top and the polythene rod is smaller, so the attraction will be stronger. The repulsion between the negatively charged polythene rod and the bottom of the aluminum foil, the force of repulsion is less as compared to the force of attraction. The reason is the distance between the polythene rod and the bottom of the aluminum foil is larger. So the bottom line is that the force of attraction between the polythene rod and the top of the aluminum foil is stronger, and the repulsion between the polythene rod, negatively charged polythene rod, and the bottom of the aluminum foil, which is also negatively charged, is smaller. So this aluminum foil will be attracted towards the polythene rod. You see, this polythene rod was actually charged by us, but the aluminum foil was uncharged. And when we bring that charged polythene rod near the aluminum foil, which was uncharged, that aluminum foil will be attracted towards the polythene rod. So this is happening when you describe this phenomena and when you explain this phenomena. This is happening because of the electrostatic induction. Do you understand this?
Yes, sir.
So, will you like to explain this thing? How this happened? Hello? Any one of you will like to explain this? I think nobody is listening. Okay, all on your screen right now, you can see a tap, and the tap is on, is open, and a stream of water is flowing. And obviously, due to the gravity, we know that the stream of water will fall vertically downward. The stream of water will be falling down straight. It will be vertically going downward. So, take a rod, polythene rod, and charge it. So the polythene rod is charged, but the water is not charged. So when you will bring the polythene rod, for example, if the polythene rod is positively charged, and this is on your screen, you can see this is the polythene rod. When you bring it near the stream of, it's not touching it, it's just to bring the near the stream of water. So what you will observe that the water, instead of going vertically downward in a straight line, it will be attracted to that charged polythene rod. The stream of water, like in this diagram, you can see that this stream of water is attracted to the charged polythene rod. The reason is, no doubt, the water is uncharged. But in your chemistry, you must have studied that the molecule of water is due to a covalent bond between hydrogens and oxygen. And in that covalent bond, the electrons between the oxygen and the hydrogen, they are shared with each other. And the pair of electrons which are shared, the most of their time they spend with the oxygen. And that's why the molecule of the water, where the oxygen atom is, that side of the water molecule behaves like negative. And where we have hydrogen, that end of the water molecule behaves like positive. So water has this positive and negative thing. So what happens when you bring a positively charged rod near the stream of water which is falling from a tap? So what you will observe, so what will happen actually, the side of the water molecules which are negative, the water molecules will turn and their negative side will be towards the positively charged polythene rod. So that negative side of the water molecule will be attracted to that positively charged polythene rod. At the same time, the negative end of the water molecule will be repelled. Sorry, the positive end of the water molecule will be repelled by this positively charged rod. But because of the difference of distance, because the water molecules will orientate themselves in such a way that their negatives will be towards the positively charged rod. So the distance between that positive side and that negative side of the water molecule, the positive is the polythene rod and the negative side of the water molecule, the distance between them will be smaller. And the distance between the positive polythene rod and the positive side of the water molecule will be larger. So the force of repulsion will be smaller because of the larger distance, and the force of attraction will be larger because of the smaller distance. So you see, the water stream will be attracted to the positively charged polythene rod. So this phenomena you can observe at your home. You can do this. take a comb, rub it in your hair so the comb will be charged, and then open a tap, slow tap. It should not be very fast, it should be slow, and bring that comb near that water stream. And you will observe this phenomena. You can do this at your home. This is happening because of electrostatic induction. This is happening because of the attraction and repulsion between the charged bodies. So this phenomena sometimes come in paper and you have to explain that why this is happening. Do you understand this?
Yes, sir.
Okay. So another very good example of this whole thing is if you have, small pieces of paper and you put them on a tabletop and you rub a comb, plastic comb in your hair, that plastic comb will become charged. And when it becomes charged, for example, it becomes positively charged. The comb becomes positively charged. And that plastic comb, once it's charged, when you bring it near those small pieces of paper which are lying on the top of a table, you will observe that those papers will be attracted to that comb. The question is why they are being attracted. The paper, the pieces of paper, they are basically neutral. And the paper is basically insulator. It do not have free electrons. So why that paper is being attracted to a positively charged rod? The reason is very simple. You see, when you bring a positively charged rod near those papers which are insulator, which are neutral, the electrostatic force of attraction, I mean the attraction between the positively charged comb and the negative electrons, which are not free electrons, but they are orbiting in their around their atoms. It disturbs those atoms. That force will disturb those atoms. And the shape of those molecules will be changed. Those electrons will be attracted to that positively charged rod. And when they are attracted, so that is the reason that those papers, they are attracted to that positively charged. So when you rub a comb in your hair, it will get charged. When you bring it near the paper pieces, small paper pieces, you will see that those small paper pieces of paper, they will be attracted to that comb. Okay? So the attraction of an uncharged body by a charged object near it is due to electrostatic induction. In the figure 35.6a, a small piece of aluminum foil is attracted to a negatively charged polythene rod held just above it. The charge on the rod pushes free electrons to the bottom of the foil because the aluminum is a conductor, leaving the top of the foil short of electrons. That is with a net positive charge and the bottom negatively charged. The top of the foil is nearer to the rod than the bottom. Hence, the force of attraction between the negative charge on the rod and the positive charge on the top of the foil is greater than the force of repulsion between the negative charge on the rod and the negative charge on the bottom of the foil. The foil is pulled to the rod. A small scrap of paper, although an insulator, is also attracted by a charged rod. There are no free electrons in the paper, but the charged rod pulls the electrons of the atoms in the paper slightly closer by electrostatic induction, and so distorts the atoms. In the case of a negatively charged polythene rod, the paper behaves as if it had a positively charged top and a negative charge at the bottom. In the figure 35.6b, a slow, uncharged stream of water is attracted by a charged polythene rod due to the polar nature of water molecules. One end of a molecule is negatively charged while the other end is positively charged. So these two things are very, very important. I read it from the book also. I explained it, then I read it from the book. The reason is that because I have seen this question in the exams. So you have to describe and you have to explain that why the stream of water is attracted to the charged rod, or why the papers are attracted to the charged form, or why that aluminum foil is being attracted by a charged rod. So we have to write these things. Okay. So that's why I am reading them also for you. Okay. So now one very important thing, let me explain it to you. The in in the buildings, you must have seen this thing. I'm talking about this diagram. On the top of the buildings, sometimes you might have seen that we have a rod projecting out of the building on the top, and it's like this. It has three spikes on it, and you will find that a rod and three spikes on it. You will find this on the government buildings. You will find that thing on the top of the big buildings, the skyscrapers. In Sagoda, we don't have skyscrapers, but the buildings which are tall, on the top of those buildings, we have this thing. And if you have seen these antenna, which are the towers, which are for these telecommunication companies, the towers of the telecommunication companies, for example, the tower of the Telenor or the tower of the Warid or Jazz or Ufone or the towers of the PTCL. If you see those towers carefully, what you will observe that on the top of the tower, on the top tip of the tower, you will observe there is a rod, and at the top of the rod there are three spikes like this, as the spikes which are showing on your screen. We call them lightning conductors. Those spikes and the rod, they are made of copper. These spikes here, the spikes here, these are three spikes, and this whole rod that is made of copper. And this is fixed on the top of the building, and this copper wire goes down, 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 and then it goes into a metal plate, and that metal plate is buried like maybe 6 feet or 9 feet below the ground. Inside the ground, it is buried inside the ground. So what is the benefit of this lightning conductor? You see, whenever there will be thunder, there will be lightning in the clouds. Whenever there will be thunder in the clouds. So you see what happens. For example, we have this scenario. Here we have a thunder cloud, and the bottom of the thunder cloud is negatively charged, and the top of the thunder cloud is positively charged. Due to this negative bottom of this cloud, you see the electrons from these spikes. These spikes are made of copper. So due to the negative bottom of this thunder cloud, the electrons from these spikes, the free electrons from the spikes of this copper lightning conductor, they will be repelled, and those electrons will go down. And this top of these spikes, that will become positive. Okay. So now you see, when this thunder cloud is on top of that building, the tips of those spikes, they become positively charged, because from there the free electrons have gone to the bottom, and the top tips of those spikes, they are positively charged. So when they are positively charged, what happens? The air molecules which are near them, they also become positively charged. So this place here becomes positively charged. So these spikes, which are positively charged, and the air around them is also become positively charged, they kind of provide attraction for the lightning strike. So if the lightning strike is going to happen, that lightning strike from here, the negative, the lightning will strike this positive, because it is high and it is positive, and the cloud is negative, the bottom of the cloud is negative. So the electricity or the lightning will strike these spikes, and that lightning has lot of charges on it. It has very high voltage. It has lot of energy when the lightning strikes. So what happens? This lightning conductor, it will provide a path for that lightning to go through this conductor into the ground. So you see, when this will happen, the lightning or the electricity through the lightning will not enter this building. So the people, the electronic things, all the wiring in that building is safe. If the lightning will strike this building, instead of falling on the building, it will fall on these spikes. And through those spikes, all the current will go through this copper strip into the ground. And your building and the residents of the building and the appliances in the building, they will be safe. So it's a very important use of electrostatics. Do you understand?
Yes, sir.
Now, a tall building is protected by a lightning conductor consisting of a thick copper strip fixed on the outside of the building, connecting metal spikes at the top to a metal plate in the ground, which is shown in the figure 3.7, which we were looking at that figure before. Thunder clouds carry charges. A negatively charged cloud passing overhead repels electrons from the spikes to the earth. The points of the spike are left with a large positive charge. Charge concentrates on sharp points, which removes electrons from nearby air molecules, so charging them positively and causing them to be repelled repelled from the spike. This effect is called action at the points, results an electric wind of positive air molecules streaming upwards, which can neutralize electrons discharging from the thundercloud in a lightning flash. If a flash occurs, it is now less violent and the conductor gives it an easy path to the ground. Another very important thing which I did not mention during my discussion is that when these air molecules around these spikes, they will become positive. So because these positive, they will repel each other. So they will move upward and they will neutralize some of this cloud. So the lightning will no more be that violent. So if anyway the lightning strikes the building, it will strike on the spikes, and through the spikes the lightning or the electricity will go through the copper strip into the ground. You understand this?
Yes, sir.
Okay. Another very important danger of the this electrostatics is when you are fueling. Okay, whenever, remember one thing, whenever you take your car to a fueling station and you see there is a danger always. There is a very important point. You should remember this thing. When your car is traveling, so what can happen that due to the friction with the air, what will happen? The car will become charged. The body of the car will become charged. So what you can do when the car is traveling, due to the air friction, the fuel tank of the car, the body of the car, that becomes charged. Remember this thing. And when you go on the fuel station, you see the fuel is coming from the oil tank, traveling in the plastic pipes, and through a nozzle which that a gas station boy is holding in his hand. Through that nozzle, it is supposed to be filled in your oil tank, in the tank, the fuel tank of your car. When the fuel travels through the pipes, that fuel will become charged. And that nozzle, which is normally of a metal, that will also become charged. So now you try to understand that that nozzle is charged because the fuel is having friction with the nozzle or the pipes, and your car is also charged. So what will happen when that boy who is filling your car, when he will touch the tank of your car, the oil fuel tank of your car, and both the bodies are charged. So what will happen when the charged bodies meet with each other? The sparks take place. Whenever two charged bodies will meet with each other, the sparks will be created. And because you are fueling your car, and there are fumes of the oil, the fumes of the fuel, and due to those sparks, an explosion can take place. So that's why whenever you take your car to a filling station, if they are working according to the safety protocol, so they will have an earth wire. What is the earth wire? It's a simple wire which its one end is connected to the body of your vehicle and the other end is connected with a rod, copper rod, which is buried in the ground. So it provides, if your car is charged, for example, your car is negatively charged. So when you will connect it, you will earth it. Earth means you connect it with the copper wire to the ground. The negatives from your car through that earth wire will go into the ground and your car will become neutral. The body of the car will become neutral. In the same way, the nozzle of uh, that petrol pump through which they are filling your car, that nozzle should also be earthed. So when you earth them, the nozzle will become neutral, your car will become neutral, so there is no chances of the spark and you will be able to avoid any kind of explosion. Another very important example I can tell you, for example, when you go, for example, you go for, we have cans. Sometimes we have cans and we take them, especially those cars which are off-road cars. They carry a can of petrol with them. So if by chance, if you go on a fueling station and you want to get those cans filled with fuel, remember it's a safety procedure that you never fill those cans while they are still at the back of your car. No. The procedure is that first of all, you will take those cans down and you put them on the ground. And then you fill them. The reason is because when they are lying at the back of your truck or at the back of your whatever vehicle you have, so due to the air friction, the body of the can will become charged. And the petrol which is coming through those plastic pipes and the nozzle of that pipe is also charged. So if you try to fill those cans while they are on the top of your car or truck and they are charged and the petrol is also charged because of the friction between the pipe, the nozzle of that thing is also charged. So when they will touch, there are chances that the sparks will happen. And there are fumes, obviously, of the fuel, and an explosion can take place. So that's why it's important to put those cans first on the ground. When you put those cans on the ground, what you actually do, you ground them, you earth them. When you touch them with the ground, what happens? All the charge on them, that is neutralized. If those cans are negatively charged, their electrons will go into the ground and the cans will become neutral. If they are positively charged, when you put them on the ground, the electrons from the ground will come onto the can and they will be neutralized. Once they are neutralized, it's safe to put fuel in them. But if you try to do that, the filling of those cans, while they are on the top of your truck, they might be charged, and you also, there are chances that the sparks may take place, sparks may be produced, and explosion can happen. In the same way, whenever an aeroplane lands, due to the friction with the air, the body of the aeroplane becomes charged. And so before you fuel it, before you start fueling an aeroplane which has just landed, it is important to ground it. It is important to connect the body of that aeroplane with a earth wire. So if the aeroplane's body is charged, it can be neutralized. For this purpose, you see the tires of the aeroplane, mostly the tires of the aeroplane are made of a kind of rubber which can conduct electricity. So what happens, because the tires of the aeroplane are conducting, they are made of a rubber which can conduct electricity. So whenever the aeroplane will touch the ground, and those tires are conducting tires, they are made of a rubber which is conducting. If the body of the aeroplane is charged, due to those conducting rubber tires, it will come in contact with the ground. If the aeroplane is negatively charged, from the body of the aeroplane, the electrons through those conducting tires will go into the ground and the aeroplane body will become neutral. If the body of the aeroplane is positively charged, the electrons from the ground through those conducting tires will go onto the body of the aeroplane and it will become neutral. Once the body of the aeroplane is neutral, it is safe, it's 100% safe to put the fuel in it. Otherwise, the fuel might be charged, the aeroplane body might be charged, and when they come in contact with each other, they may produce sparks, and the fuel has fumes, and in those fumes, the explosion can take place. It's very important. You see, I have put a lot of emphasis on this thing. The reason is that because this thing comes in paper also, and you have to write these things. So I can read from the book also, the refueling sparks from the static electricity can be dangerous when flammable vapor is present. For this reason, the tanks in an oil tanker may be cleaned an atmosphere of nitrogen. Otherwise, oxygen in the air could promote a fire. An aircraft in flight may become charged by rubbing the air. Its tires are made of conducting rubber which lets the charge pass harmlessly to the ground on landing. Otherwise, an explosion could be sparked off when the aircraft refuels. What precautions are taken at petrol pumps when a car is refueled? In the same way, I'm not going into discussion now. Operating theaters. Dust and germs are attracted by charged objects, and so it is essential to ensure that equipment and medical personnel are well earthed. This word earthed means that the body of that object with the copper wire, a copper wire is connected to the body, and that copper wire is, the other end of the copper wire is attached to a rod which is buried in the ground. This is called earthing. This is called earth wire. This is called grounding. Dust and germs are attracted by charged objects, and so it is essential to ensure that equipment and medical personnel are well earthed, allowing electrons to flow to and from the ground, for example, by conducting rubbers. Computers require similar anti-static conditions as they are vulnerable to electrostatic damage. Okay, so that was these are the hazards of your here we have also I think we just have 5 minutes. Let me finish this. The phenomena of lightning occurs due to a large quantity of electric charge which builds up in the heavy thunderclouds. The thunder clouds are charged by friction between the water molecules in the thunder clouds and the air molecules. When the charge on the thunder clouds is sufficiently high, it induces opposite charge on the objects present on the ground, giving rise to a strong electric field between the cloud and the ground. Suddenly, the charge in the cloud jumps to the ground with a violent spark and explosion. This is called lightning. To prevent lightning from damaging tall buildings, lightning conductors are used. The purpose of the lightning conductor is to provide a steady discharge path for the large amount of negative charge in the air to flow from the top of the building to the earth. In this way, the chances of lightning damage due to sudden discharge can be minimized. Okay? And the last thing is fires or explosions. Static electricity is a major cause of fires and explosions at many places. A fire or an explosion may occur due to excessive buildup of electric charges produced by friction. Static electricity can be generated by friction of the gasoline being pumped into a vehicle or container. It can also be produced when we get out of the car or remove an article of clothing. Static charges are dangerous. If static charges are allowed to discharge through the areas where there is petrol vapor, a fire can occur. Okay? This is for your information. The energy in the lightning is enough to crack bricks and stone in unprotected buildings and destroy electrical equipment inside. Each bolt of lightning contains about 1,000 million joules of energy. This energy is enough to boil a kettle continuously for about 2 weeks. A flash of lightning is brighter than 10 raised to power 7 light bulbs, each of 100 watt. During flights, during flight, body of an aeroplane gets charged as the aeroplane lands. This charge is transferred to the ground through the specially designed tires. Static electricity can spark a fire or explosion. Care must be taken to avoid sparks when putting fuel in cars or aircraft. Sparks may be produced due to friction between the fuel and the pipe. This can cause a serious explosion. The spark can be avoided if the pipe nozzle is made to conduct by connecting an earthing strap to it. Earthing means the ground wire. Strap to it. The earthing strap connects the pipe to the ground. So today we have learned about some of the uses of the, not the uses, but the static electrostatic induction and some of the hazards of the static electricity. So I hope that to some extent this lesson is useful to you. So I think that the time of our lesson is over. So we thank you very much, everybody, and have a good day and God bless you all and have a good weekend.